So today is day 3 of the geometric sequences in series, and we're going to be focusing on the series and looking at summation notation as well. So our first example, we're looking as well as the sum of the first 10 terms for our geometric sequence. So the first thing we need to do is use that explicit formula for the geometric sequence. So the 10th term equals the first term times the common ratio to the n minus 1 or 10 minus 1 power. So our first term is 12. We need to find our common ratio. So 18 divided by 12 would be 3 halves to the 10 minus 1 or 9th power. And I got a decimal on this one. It's about 461.320 if we round to 3 decimal places. What's nice about the geometric series formula is that you don't need the last term. You just need to know how many terms. So we take our first term times 1 minus the ratio to the nth power, or in this case the 10th power, over 1 minus r. So we get 12 times 1 minus 3 halves to the 10th power divided by 1 minus 3 halves. Careful with the order of operations again when you're punching this in. And I got about 1359.961 for that one. So looking at our sigma notation for a geometric series, with this one, again, we don't need the 5th term, we just need the first term. So I'm going to substitute 1 into my formula. 1 minus 1 gives me the 0 power, 2 to the 0 power is 1, 1 times 4 is 4. We do need to know that we are summing 5 terms, so that's where the number on the top is helpful. And we need to know the common ratio. Remember, the base of your exponential is the ratio because it's the first term times the ratio to the n minus 1 power. So our sum is 4 times 1 minus 2 to the 5th power over 1 minus 2. So when we punch this into our calculator, we get a sum of 124. The last thing we're going to take a look at is comparing an arithmetic sequence to a geometric sequence. So take a moment to ponder this question. Which do you think is a better deal? If you save $100 every day for 30 days, or if you save a penny on the first day and double the amount you save per day? So our arithmetic sequence, if we save $100 a day, is pretty boring because our first term is 100 and our second term is 100 and so on. So if we're writing the first 5 terms, we're saving $100 every day. So our common difference is 0. So when we write our recursive formula, t sub 1 is 100, t sub n equals the previous term plus the common difference, or if you wanted to simplify that, t sub 1 equals 100, and t sub n equals the previous term. Our explicit formula isn't much more exciting. So we would start with t sub n equals t sub 1 plus d times n minus 1. Well, our common difference is 0. So all of that, 0 times n minus 1, cancels. T sub n equals 100. So when we're finding the sum of the first 30 terms, we would take the number of terms times the first term plus the last term all over 2, which gives us 30 times 100, or 3,000. So we would end up saving $3,000 over 30 days. To write it in sigma notation, we would start with k equals 1 to 30, because we're saving for 30 days, of 100, and that comes from the explicit formula that we wrote in part C. Don't let it confuse you that there's no variable. All that means is that your first term is 100, your second term is 100, and so on. And so this comes from our sum formula. We saved $3,000 over the course of the month. So now let's take a look at that penny a day and doubling it. So our first 5 terms, the first day we save a penny. then we save 2 pennies, then we save 4 pennies. So that's 3 terms, and we save 8 cents and 16 cents. So the first 5 days don't look real impressive compared to our arithmetic series. The recursive formula, our first term is a penny, and then each additional term is the previous term times 2. We're doubling the amount we save each day. Explicit formula for our geometric sequence, our nth term would be the first term times 2 to the n minus 1 power. So I'm going to save actually finding the sum until the last part, but to write our sum formula, S sub n would be n times, sorry, I was thinking arithmetic, let me back up on this one. Let me remember my geometric sequence. So it would be term 1 times 1 minus the ratio to the nth power. Sorry, and our ratio is 2, so let me fill that in as well. Over 1 minus 2. And then we'll fill in the n when we get to the end. To write it in sigma notation, again, we're starting on day 1 through 30 days, and then we just take that explicit formula that we wrote here and put that in for what we're summing. How much money do we save on day 10 alone? We looked at the first 5 days and we were only saving 16 cents on day 5, so how much more impressive can that get? So we use our explicit formula, equals a penny times 2 to the 10 minus 1 or 9th power. So a penny times 2 to the 9th power gives us $5.12. Still not real impressive. But when we look at how much we've saved through the 30 days, this is where we're going to finish evaluating that sum formula. So we had S sub 30 equals our first term times 1 minus 2 to the 30th power over 1 minus 2. And this gives us a sum of I have to figure out where all my commas go. $10,737,418.23. Much, much more than the $3,000 we would have saved with the $100 a day.